welcome to my crib! Let's get down to business. Let's do some chemistry. Not the Breaking Bad kind, but the equilibrium kind. Welcome to our over easy problem. Get it?
They're eggs, if you can't tell.
So, we've all seen this equilibrium equation before, which is why it's our easy problem. So we have H2 gas plus I2 gas creates 2HI gas. And in this case, it's going to be a forward reaction because our K is 10, which makes it a forward reaction. We have a given partial pressure, so the H2 is 2 atmospheres, the I2 is 1 atmosphere, and we know this is going to be 0, so it's a forward reaction. And we know that this is going to decrease, so these are negative, and that this is going to increase, so it's plus. And the reason we brought the 2 down from here is because the 2 was given, and that's how it's balanced in the amount of moles and science, math stuff. And so this is chemistry. And so this is 2x, this would be 1 minus x and 2 minus x. This question is asking what are these different partial pressures at equilibrium. So first we'll set it up as in any normal equilibrium equation. So we have our K is equal to the products over the reactants, and in this case we have x's involved, and so we set this equal to 10. And eventually we'll come to the point where we find out where x is. So our x ends up being 0.79, and this is how we found it. So we set this equation up that we did earlier. We moved it to here and we rearranged it to get x by itself. So first we multiplied the denominator times 10, and we got 20 minus 30x plus 10x squared equals 4x squared. And then we got it all on one side to make the equation equal to 0. So we got 20 minus 30x plus 6x squared. And so our A is 6, our B is negative 30, and our C is 20. And we use the quadratic formula to figure out all our things, and we end up with 2 answers. One of them will be negative and one of them is positive, and the x is our positive number, 0.79. And so to find these final equations, we'll plug them into each one. So we know the equation for H2 is going to be 2 minus 0.7 I2, and then finally HI. We know the I2 is going to be 1 minus 0.79, and we know that this is going to be 2 times 0.79. And eventually this will be 1.21 atmospheres of H2. This will be 0.21 atmospheres of I2, and this will end up being 1.58 atmospheres of HI. And that's how you find the partial pressures of this equation. Rachel out.
Y ahora vamos al siguiente problema que se llama mediano problema. No, I'm just playing. So you have 2 BrCl, and then it reacts and then becomes BrCl, and you're giving your initial concentration, so you have 1 of your reactants and 0 of your products, and because there's a 2 right here, you're decreasing or subtracting 2x, and then here you're adding x and x, because there's 1 and 1. So then to find your equilibrium, you're going to do 1 minus 2x, and then just x and x. And you're given K in this problem, so K equals 5.81, and then you set it equal to the equilibrium concentration equation, which is products over reactants, and then you just put in your equilibrium concentrations into your equation, and then you do all the math to get x alone, and because this equation has a perfect square, you can just square root both sides, so then you get 2.41 equals x over 1 minus 2x. You multiply that by both sides, then you distribute, then you subtract this to put it on the other side, and then you get x to equal 0.41, and then you put X into your equilibrium concentrations to find out their numbers. I need a cough. Tress, go.
Welcome to our hard-boiled problem. Because of the eggs. Okay, let's start. So we're given this nasty equation, right? And they're saying, what's these concentrations at equilibrium? Well, first, when we're doing an ice table, we know that the only things that we can use in our ice table are gases and aqueous solutions. So this is a no, this is a no because they're solids. So it's a forward reaction because of the given K, it's 0.25. So we're going forward. So this is plus X, and these concentrations at equilibrium are going to be X. So we'll set it up like any other equation. K is equal to the products over the reactants, and so we plug it in, and we end up getting 0.25 is equal to X squared. So we square root both sides, and we get X equals 0.5. So the concentrations are 0.5 and 0.5 for CO2 and H2O. Moving on to B. So now it's asking, what are the solids molar masses at equilibrium? So first we start with our good old friend Piv nerds. It never leaves. So we set it equal to N to find the moles of this concentration of the CO2 and the H2O. So we know that N is equal to 1 liter. All this information is given times the 0.5 atmospheres all over 0.0821 times 398. The temperature is also given. We end up getting this lovely number of 0.0153 moles, which represents both CO2 and H2O. So we'll use our good old friend stoichiometry and go from 0.0153 moles of carbon dioxide and eventually change that over to the NaHCO3 to grams, and we get 2.57 grams. And so we know we were given this amount of grams, and it's asking, well, this much was used, what's left? So we'll just subtract these numbers and we get 7.93. And we'll do the same thing with the Na2CO3. So we'll use, there's this many moles, the Na2CO3, and then we'll change it to grams. We get 1.62. Yolani will finish this problem.
Okay. See, it's saying, what is the volume when given 10 grams of NaHCO3? So you use stoichiometry again to convert grams to molars. So then you guys should already know how to do that. And then with that given information, you set it equal to find the CO2 by doing the mole ratio. So then you get this number. And then you set it all equal to Pivnert. That thing just never goes away. And then so you get volume, and you just set it up equal. You plug in all the numbers, the temperature was given, everything else is given, and then you set it equal to volume, and you solve for it with your use your calculator, and you get 3.89 liters.
Thanks for watching Chemistry for Dummies.
# Archer School for Food. Wait, no, SAS.